In the B part of Learning Assessment 814, we're going to use Thevenin's theorem to find V0. We're going to utilize a problem-solving strategy entitled AC Steady State Analysis and applying Thevenin's theorem. And if we remember back to Thevenin's theorem, step 1 said remove the load and find the voltage across the open circuit terminals. Well, first we need to decide what the load is. And V0 is across this element, so let's let that be the load. And if you remember, when we get a Thevenin equivalent, our circuit will be the following. We'll have an open circuit voltage, our Thevenin impedance, here's the terminals A and B, then we'll hook our 2 ohms back up to that and calculate the voltage V0. So then our task is to find the open circuit and Z Thevenin, and for reference on our circuit, here are points A and B. So now our task is to go through and find the open circuit and Z Thevenin, and as the problem solving strategy states, we'll now go in and remove the load and find the open circuit voltage at the terminals A and B. So here's our circuit for calculating the open circuit voltage. Now if we notice, if we apply KCL at this node, we know this is 0. So then we know there's J2 amps flowing around there, and we can find VOC by applying KVL to the outside. So if we start here and go around, let's go around counterclockwise. So we'll have 24 at an angle of 0 minus VOC plus 0 plus J2 times 2 equal to 0. Then what we'll get is that VOC is 24 plus J4 volts. So that completes the calculation of the open circuit voltage. Now, our next step is to find the Thevenin impedance. Now we'll take this circuit, for instance. We're again to look back in, but we're going to take our sources and turn them to 0, and we're going to find the impedance looking back into this network. So here is our circuit, and remember our current source was here, and when we turned it to 0 it becomes an open, and remember that our voltage source was here. We turned it to 0, it became a short. So if we look then, Z Thevenin is 2 minus J2 ohms. So now we've calculated our Thevenin equivalent, and we're ready to reconnect our 2 ohm load and calculate the voltage V0. So here's our circuit now. Here's the open circuit voltage. Here's Z Thevenin. So now to calculate V0, we can use voltage division. So we have 24 plus J4. We want the voltage across the 2, so we have 2 over 2 minus J2 plus 2. And that's 8.8 plus J 6.4, which is also 10.88 at an angle of 36 degrees.